All right, guys, let's go through the warm-up. All right, guys, up here. Okay, so first one, find the inverse. What do we do to find inverses? Yeah, so are we okay with jumping to x equals 3y plus 2 over 2y minus 5? Good there? Okay, now what?
I have to get. So do you multiply? Yeah. Both sides by 2x. Oh, they cross it.
And then we distribute over here, so I get 2xy minus 5x. Now, guys, this is the spot where a lot of people get stuck. I see some people kind of going in a circle where they get there and then they go, oh, now I'll factor out an x. Well, okay, then you're back to where you just were, so that does nothing for you. What are we solving for? Y. So I need to get all the y's on one side. Do you have a question, Julian? Or?
No, I just have a suggestion.
Okay, well, hold on. All right, guys, are we okay with that? You're just moving things around so that everything with a y is on one side. Everything without a y is on the other side. Factor out the y. All right, Julian, last step. Yep. And guys, do I want to end with y equals, or what should I use? It's freezing in here this morning, so I have no idea. The temperature is a mystery. All right, guys, how many got number 1? Yay. Okay, we can find inverses.
I did get it.
Yay. All right. Domain, that's what I'm asking you for on the second one. This one is usually a little harder for you guys. We have 2 parts that we have to look at. I have a denominator of a fraction, that causes an issue, and I have a square root. What can I not take the square root of? Negative numbers. So what is under the square root, the x squared minus 4, must be greater than or equal to 0. I'm going to deal with the denominator in a minute. We'll start with just that numerator part. Is not. Like, that's going to come into play, but that's not what it equals, okay? I need to factor this and set up a number line, okay? Yeah, okay. It's in your brain somewhere.
Yeah, no, I think.
Okay, so what are the 2 numbers on my number line?
-2 and 1.
Yeah, that's where the plus or minus 2 come in. Okay, what number is easy to test? 0. Where does 0 live? In the middle. Hey guys, up here. So 0 plus 2 would be positive. 0 minus 2 is negative. So what does that make that section? Negative.
No.
Will this alternate? Yes. Okay. So, yeah, we've done this many times. It's just, it keeps coming back. I want greater than or equal to 0. So are we okay with it the ends and not the middle? Would I include the 2 and negative 2? Yes. Yes. Good. Okay. Now I have to think about the denominator. So over here, what can x plus 7 not equal?
Negative 0.
Oh, you say negative 0?
I meant like 0, because then you move it over, then it's negative 0.
Okay. So x cannot equal negative 7. We're okay with that, right?
Well, why is the left side positive?
Because if I do negative 3, like if I plug a negative 3 in, negative 3 plus 2 is negative 1. Negative 3 minus 2 is negative 5. Negative times the negative is?
Negative, oh, it's positive.
Yes.
Okay.
Yep. Okay, so guys, I'm not making a new number line here. I'm just drawing this one bigger so we can see everything that's happening. With our initial number line, we came up with this, right?
Yeah.
And then we said x cannot equal negative 7. That means you have a little open circle at negative 7. So how do I write my domain? Yep, with a parenthesis on it, right? Yeah. Yes. Perfect. Yay! You had like the plus or minus 2 thing going on, or what'd you do?
Yes.
Okay.
But I got that.
That's interesting. Your brain must have been like.
Because I looked at the notes earlier and I had to sample this and know why.
Ah, okay. So you're like, I think this goes here, but I don't know what I'm actually doing.
Yeah.
Okay. Well, now you know what you're doing. Even better. How many got the domain right? Okay. Fine. Anybody questions on it before we move on? Yes. Because it can't work in there. If I pick anything in between here, I'd be taking the square root of a negative. So we have to skip over that part. All right. Anything else? All right, guys. Any questions from the homework? No, that's why I said skip 13. Yeah, skip 13. That was the one. Don't do that one. Yep. I don't think it works.
Okay, I put that.
Okay, you're just like, here's some work that doesn't really. And no, not inverse. On 9-3.
No, like doubles. There's like 2 nines.
Number 13. Just skip the one. Number 13. There's not two number 13, right?
Yeah. So like,
So the one that's number 13. Okay. All right, guys. Notes for 9-4. I have a worksheet for you. Don't like renumber it. Yeah. He was like, I don't know what that's.
no, it's like there's 2 nines.
But there's not.
But you guys didn't flow up then.
You wanted to renumber it, and then you didn't know what number it was. Okay, your face during that whole
How did this thing go?
No more pickleball? Pickleball? What are the All right, guys. Let's look here. My graph's got kind of weird up here. You can see mine isn't centered anymore. Yours is. We don't really need to graph a lot here. Okay. Guys, up here. Because I'm not going to talk over you, okay? So. Are we ready, guys? Okay, so symmetric to the y-axis. Everybody knows where the y-axis is, right? Okay, symmetric to that means if you fold the graph in half along the y-axis, the points would match up. You like flip across the y-axis. That's what we're doing here. So if I think about the point 2, -3, and again, my axis is weird up here. Yours should be normal. That's where 2, -3 is for me. If I want to reflect across the y-axis, that would be over here, right? Where the green dot is for me. You see that okay? What ordered pair is the green dot? -2, -3. So if you're reflecting across the y-axis or symmetric to the y-axis, what changes? Just the x, yes. Just the x changes sign. So looking at those other 2 points there, -1, 2, what would be the point? Okay, these are quick, right? 4, -2 is going to become -4, -2, right? You don't have to plot all of these. I think you get what's happening, right? So that's symmetric to the y-axis. You're flipping over the y-axis, your x changes sign, okay? So, if we're symmetric to the x-axis, flipping this way now, what's going to change? The y. So 2, -3, what's going to be symmetric to that? 2, 3. What about -1, 2? Okay. And 4, -2?
4, 2.
All right. Easy so far?
Yep.
Okay, symmetric to the origin. Guys, somewhere on your paper, like, I don't know, just squeeze it in somewhere. Sketch this little graph. Sketch the cube graph for me, okay? Draw that on your paper. All right, once you have it drawn on your paper, hold your paper up in front of you like this, with the graph towards you, okay? Everybody hold up your paper. Rotate your paper 180 degrees. Okay, look at your graph and look at my graph. Oh my gosh, some people got stuck. Anywhere on your paper, just draw that graph and then rotate it 180 degrees. Looks the same, right? That is being symmetric to the origin. We're having rotational symmetry. Rotates 180 and it looks the same. Yep. Tyler's just going to be going in circles back there. All right. So you're rotating 180 degrees. That means you're traveling like 2 quadrants away. So what do you think is going to happen with the signs on your x and your y? Yeah, they both change, and that creates symmetry to the origin. So 2, -3 is going to become 1. Okay, we got this. Okay. All right, so those are the different types of symmetries. Let's talk about those with even and odd functions. So first one here, even functions. The function is even, it has symmetry to the y-axis. So let me draw for you x squared, sort of. All right, little parabola, right? If you fold that in half along the y-axis, are the sides of your graph going to match up? Depending on how you drew it, hopefully they will. That is called an even function when you have symmetry to the y-axis. So graphically, you can see it. Algebraically, we're going to prove it, which anytime I say prove, what do you know that is going to involve? Work. Yes, work. Clearly written, organized work. Looking at some people specifically. You're going to go in like a spiral for me? Okay. All right. This one's very basic, but let me show you how we do this. So we started with f of x equals x squared. We have to show that plugging in a negative x gets me back to the original function. That I can plug in a negative x and it's just the exact same thing I started with. So for this function, I'm going to write in parentheses negative x quantity squared. That's the plugging in of the negative x. What happens when I square a negative? So this is really positive x squared. Do you see how the original and what I ended up with are the exact same thing? Okay, that means this is an even function. Okay, so you plug it in, show the work and simplify. If it's exactly the same, it's even.
The answer is the same.
What they simplify to, if it's exactly the same, yes. Okay, odd function. That's like the cubic function we drew. Maybe you already drew it in this little spot. Symmetry to the origin, right? Ooh, that one really doesn't look so good, but you get the idea. When you plug, oh, yes, Van.
Sorry. So for the last one, what was that like? Was that meant to be symmetric to the y-axis?
Yep, symmetric to the y-axis.
Oh.
Yes. Yep. All right, so we're plugging in our negative x here. What you need to have happen for it to be an odd function is that you get the opposite of what you started with. That's what that negative out in front means. So the O's go together. The odd function is opposite. Okay, so if I plug it in, I'm going to show negative x quantity cubed. Well, what happens when I cube a negative? It's still negative. So this is negative x cubed. So again, do you see, looking at the original to the one we simplified, do you see how it's the opposite? Opposite means odd functions. Now, you could also get something that's not the same and not the opposite, okay? That's just neither. It's not even or odd. You just know. That's a choice, okay? All right. So let's try a couple of these down here. Let's do number 1 together. So again, we're going to practice showing the work what you have to show me every time. We're going to do f of negative x. So I plug that in. 2 times negative x plus 1. Okay, so when I simplify that, I have negative 2x plus 1. Compare original to simplified one. Is it exactly the same? No. Is it the complete opposite? No. So, neither. Is this stressing you out?
Yeah.
Oh no. All right, try 2 and 3 for me. Try 2 and 3 on your own, then talk to your neighbor.
Sorry, that's me. That's right.
We have to show the work.
Well, if you are wanting the credit, yes, you have to show the work. If you don't want credit, you certainly don't have to. It's like the proof. The work is part of the fun. Check in with each other. Even, odd, neither. How we doing?
You're a smart guy too,
James, that doesn't mean get your phone out. Are we ready, guys? What's our vote for number 2? A lot of evens. Let's show the work and see. Exactly the same. That is even. Okay. Yeah. What'd you get for number 3? Odd minus 1. Complete opposite. Yes, 2 odd. Okay. So far, so good. Okay. The other thing we're going to add is we're going to add fractions. So you just have to think a little bit more about your fractions. But if you think back to numbers, I think it makes sense. So let's think about the fraction 3/4. All right. Now, this question shouldn't be hard, but sometimes I get weird answers. What is the opposite of 3/4? Negative 3/4. Guys, 4/3 is the reciprocal. All right, opposite of 3/4 is negative 3/4. Okay, let's think about that in terms of exactly the same and completely opposite like we were doing up above. I could have the numerator be the opposite and the denominator be the exact same thing, right? And that overall makes the fraction negative, yes? Could it also be like this, 3 over negative 4?
Yes.
Yeah, I could have same over opposite. All right, and that would still overall be the opposite of the fraction. Okay. What about negative 3 over negative 4? Right, because that's, oh, here, grab that's the homework worksheet. That's how come. Yep. So if you have opposite over opposite, that's really same. Okay, I know that sounds weird, but two negatives make a positive. You actually have the exact same thing you started with. Does that make sense? Two wrongs make a right. Yep. She's not going to agree with you. All right, so let's try one. Let's do number 4 together. Okay, so we're going to do J. We've gotten to J's, apparently. We're working our way through the alphabet. So J of negative x, that's going to be 2 times negative x over 3 times negative x quantity cubed minus negative x. Okay, so when I simplify the numerator, I have negative 2x. Denominator, are we okay with negative 3x cubed plus x? We're okay with the simplifying. Okay. Hold on. Yeah, you're good with the simplifying. Okay, so now look at each part of your fraction separately. The numerator, is it the same or opposite or just neither? Opposite. So we got opposite over another opposite in the denominator? Yes. So what does that actually mean? Same, which is even. Yes. Do we see it? Okay. If either part, the numerator or the denominator, is just not, like it's not opposite and not the same, answer is neither. You don't have to look at both of it. If any part of it is an either, it's an either.
Either.
Ricky? No.
It's still 3x cubed plus x. Is that also either?
It was minus to begin with, though.
Yeah. But it's not the same.
It's the opposite, though. Right? All the signs changed in the denominator?
Yeah, but if it's negative. Positive.
Yep, which is why we said even.
But then stuff that's the opposite.
But so much of it is the opposite that it's actually the same. It's like your fraction. If you have 3/4, we had an opposite numerator and an opposite denominator, which makes it the same. So
I get the negative over negative. Aggregate positive, but then what about the plus x? How does that go back?
because this whole thing is opposite, right? So you could write it this way if you wanted to. You could factor out the negative. You could say, okay, this is really
That makes more sense.
and then cancel out your negatives, and that's even. Okay.
So what if I put neither, but my teacher says neither?
Well, you're not pronouncing it on your test. You're just writing it. So I think I've said it both ways today too, because I can't decide. All right, try number 5 for me. Not that one. Dan, you look like you have a question.
No, actually, I can.
Okay, do number 5.
I was just thinking.
Okay. That's allowed.
Wait, does the left expression of like x matter? Like change
Just function notation.
Negative x squared is x squared.
We'll see in a minute.
But that's kind of.
Oh, I very much.
Oh, no, so I have a question. If I'm on the test and I get to the part where I put like negative parentheses, negative x, and then find square, like I get to what it was, like x squared minus 5 over negative 2x to the third plus x, I'm just going to get out and try to figure it all out.
Gotta show your work.
But it is.
Again, your choice. You can choose not to, but then I am choosing the grade you get. You are leaving that up to me, though. All right, guys, what do we think? Odd? Are we all in agreement? Let's see. Show the plugging in. Numerator stays exactly the same. Denominator's opposite, so overall, yes, that is odd. What happens when you square a negative? Yeah.
Because it doesn't matter.
Well, no, it becomes positive. It's not that it doesn't matter. What's a negative times a negative? All right, guys, questions so far? Okay, try number 1 through 6 at the bottom for me. I'll give you a few minutes here. Yes, show this. You must justify algebraically. That's the whole showing your work part. Do these 6.
You have to show like in the brackets the negative.
Yep, that's part of it. You guys all trying to squirm out of your work here.
But like technically, if I know that this is gonna switch like to a negative, couldn't I
Here's
just
what
write?
would happen. Just take your test here and be like, where is this?
I know it's gonna become this.
Well, yay, then write it down and write this.
Okay. Okay, but like that's right though.
I'll be like writing like
True.
sad faces on your face.
Okay.
Like it doesn't even say either one. Like it just says and then I'll use the See, this is why I did. Hopefully we won't have a point. What are we gonna do after this awesome test? Didn't you say the last test was or maybe that was what about
Guys, are we ready? I know. Neither, yeah. So that it's a line. No, I'm trying to think. What other word has that, and how do I say it? I'm struggling. Like weight, W-E-I-G-H-T. But then I'm like, wait, is it nether? Now we're overthinking. All right, guys, let's go through them. What'd you get for number 1? Even. Do we all agree? Even. Do you need me to show you the work? I know you don't want to write the work, but you need to see the work. Okay.
Really? So like your shirt.
Oops, that's 4. So a negative x to the 4th is positive. Negative x squared is positive. It is the exact same, so that is even. Okay? What'd you get for number 2? Even. What'd you get for number 3? Yes. What about 4? Neither, neither. Yes. What about 5? And 6? Odd. Any questions on those guys? Do we like even and odd? Other than you don't want to write things down, do you like even and odd?
Yeah.
Okay. We're going to do a quizzes. So partner up if you would like, or do it on your own if you want. I don't care.
This one.